Good morning, everybody, and thank you for gathering here today. And kind of pressure's on for me because I'm the first one up, and I just landed yesterday from Los Angeles, so I'm a little bit frazzled. But I'm going to be talking about intensifying architecture. What does that really mean? Yesterday I had the great pleasure of visiting Trinity College and seeing the great collection there. And you can see that the vast amount of knowledge that is just collected in a place like this. And our task as an architect, we're constantly looking at information and trying to process it and make sense out of it. So it's about intensifying, but it's also about simplifying. Because it's easy to make things complex. It's actually very difficult to make the complexity simple and make it relevant to decision making. So I had a little fun with the magazine cover here. I said, okay, BIM is the new black. I'm coming to Dublin. This is my AIA number there, right? I'm going to be a little bit provocative today, so if I say anything wrong, you could basically turn me in. So, so I'm very glad to be here. It's my first trip to Dublin, so I'm very excited. My first name is actually Greek. I'm half Greek. So entasis in Greek and endasis is about strain, stress, and intensifying. That's the meaning of the word, the root meaning of the word. And what that really comes from is if you look at the Greek orders and columns, and the entasis, the curvature of the column that makes it straighter than being straight. Basically, it's that forced perspective that happens. And it's basically a set of rules. And if you look at these rules, it basically is what drives a lot of decision making on the design process, but it's not overly prescriptive. In other words, it gives you the basis for doing something with it and creating great architecture. So it's a very important concept as we go forward. It's about how to make the complexity simple and to keep building up over time and sharing that information and building up with that. So this is a technology in a sense. The Greeks have had a lot of problems recently, but one thing they've really nailed in the past is about architecture, the basis of what architecture is about. And I look at this as a piece of software, actually. I call it Marble OS, whatever we want to call it, but basically it's embedded with information that we can use to work off of. So the complexity that has been around us, and that still is, it's actually the complexity is increasing with the increased need to collaborate and connect. It's not going to get less intense. So how do we take this complexity and actually make it simple? And one thing about all this is everything in the last few years, absolutely everything that we know about technology has been turned upside down. It's turning industries around, it's turning technology companies around, it's turning our expectations about how we get access to data around. We need to make things simple because things are more complex. And we also have realized that it can't be all done in one piece of software, it can't be all done with one organization, it can't be done with one country. And certainly in the building industry, the complexity is just absolutely immense. So it's an opportunity, I think. It's a challenge, but it's an opportunity that we have to step to. We have to step into this world of what do we do with this complex information to make it simple and boil it down to this. So, for example, if you had a paper map in the past and you wanted to find Starbucks, it would be a different task than it is today. You basically expect to be able to point to something and find the nearest Starbucks as one example. And not only the Starbucks, but other information about where are my friends and how's the traffic and what does it look like in 3D. So it goes on and on. But in the background, the data is being fed to you. You're not expected to know the complexity of the data and the technology in the background. It's just driven to you. And the reason this works is because it's real time. Imagine if you had to go to a website like this or an app like this and have to download a PDF of all the Starbucks in the world and print it out and put it on a shelf, or even save it as a PDF and then find that. And I use the airline reservation system as another example. When we make an airline reservation, we don't go to an airline reservation site and print out every schedule that there is out there and put it on a shelf and expect to come back 2 weeks later or even 2 hours later and be able to buy that seat. The reason it works is because it's real time. It's being driven to you in a format that you can consume and react to. And it's not asking you questions like how much fuel would you like on the plane. Somebody else is taking care of that, so that plane gets up in the air. So the complexity of information and the digital tools that are around us have absolutely changed everything else except the building industry. We're heading in that direction, but we have to be proactive about how do we bring ourselves into this world because it's already happening around us. And if we don't move in, we can't wait, in other words. We can't wait for an answer. We have the answers about how to do this. So information around us, this is Los Angeles, we call it building informed environments. And what's an informed environment? An informed environment is finding Starbucks, but also finding the conference room on the 53rd floor, and what's the capacity of that room. All of this information, even though buildings look like they're static, they're constantly changing, right? Just like the bus that's moving around. If you think of buildings and facility management, information is constantly shifting and changing, and we have to react to that. As an architect, I've also seen that as an opportunity. If we can understand how to use this data about facilities, there's huge value for a single building owner, a portfolio building owner, a government, whatever. It scales to any scale, whether it's a single building or multiple buildings. And that's really exciting to me. If you look at this information from a point of view as being an asset, as a value, how can we turn that value around and help us and help our clients and customers and help us to collaborate? And Twitter is another example. Basically, as you start seeing this kind of stuff coming up, it basically gives you information about what's happening in a location. What's happening at CETA Dublin today. I'm sure there's tweets. They have been going online for the last few days as well, too. But this is real-time information that's being fed out there. So there's also a higher calling, and we've all seen this before. I mean, there's climate change and the oceans rising and all that kind of challenge that's out there that can't wait for us. This is a very important concept. The world cannot wait for all our buildings to be in BIM before we make decisions about how to react to challenges like this. Very important concept. We can't wait for all buildings to be in BIM, or our interpretation of what BIM is. So I want to kind of shift that around and refocus the attention of what is BIM. BIM is, we love, and as an architect, we've been doing BIM for 22 years. I've been at this since 1993, starting in ArchiCAD. And the first few years I got in there, got really excited. Well, in the next few years, everything's going to change, but it's taken a while. But now is the time. Now all the technologies are starting to come together to make this possible. So how do we use the information that is in our facilities, whether we call it BIM or not, to make decisions about what we do about climate change or construction cost or facility management? It doesn't matter what you call it. It's all information that drives decision making. And the way that I think that has to happen, it has to come from a bottom up and a top down, or a push and a pull. There needs to be a push, but it also needs to have a pull. We can't, and this is what's driven me crazy as an architect for many years, we did not wait for our clients to say, go and use BIM. We basically moved out there and started using it, and that's created incredible opportunities for us and for the consultants and other teams that we work with. So to be able to pull other parts of the industry in without requiring them to even understand what BIM is, what does that really mean? Last week, Arto was going to be presenting later, and I were actually in Shanghai presenting at another BIM conference, and he had this slide, and it's really caught my attention. It's a slide by his PhD student in Canada that says it's not all about the technology. It really isn't. Technology is a piece of that, but it's a process in the organization and a lot of other things that you have to push uphill. And this, as being part of Building Smart and standards organizations for many years, I know that this was happening, and we've been a big supporter of that for many years. But there's also another side to this. The push is uphill, but I have found over the years, and I'm a big supporter of IFC, so I'm not saying IFC is bad. I'm just saying it can't be only IFC. This has been a huge challenge. IFC is incredibly important, but if we think everything is IFC and become dogmatic about it, it's really been a hindrance. And I've said this privately over the years, and I think publicly now I want to push on it really much more, and I think we can use this event as part of this discussion of IFC is important, but in order to engage the non-BIM world out there who care less about IFC and about BIM, we have to think in terms of data. And how is that going to work? So IFC, for example, moving from one BIM application to the next, you need the full IFC model to move it. So yes, we have to do that, and even in the tool, we build our own IFC software as well. We've built that over the years. So it's not that we're not going to use it, but it does take a heavy lift. And I believe it's part of the reason why this feels like we're pushing uphill right now to get BIM, to cross that chasm. So to remove all the friction of IFC, we need to think of IFC and other types of information. This is I'm getting a little techie here, but this is the stuff that happens in the background that needs to be easy for us to use as non-technical people, non-tech software developers, but also to engage the other part of the world out there that's building these apps, for example, that know nothing about BIM but are great at building apps. They can consume data like crazy, But if we put in front of them, if we go to somebody that's building an app on an iPhone or an Android and say, before you can work with us in the BIM world, you have to understand IFC. That's a non-starter. They'll go screaming into the woods because they want to do stuff over the weekend, not over this next several months. So it's not one or the other, but it's both. Incredibly important concept for us. And how does that happen? We have to reduce the friction. We have to create a pull. And one way to do this, which I'll show you case studies of this, is to use web services. Web services are a way to broadcast information out there and have other applications use that data. So for example, when you pull up an app on an iPhone and you see a map, you don't have to build a map application. You basically use the maps that are out there and plug them in. And you plug these pipes together and you can basically start getting data in a format on your mobile device from, you don't care where it comes from in the end. It's basically giving you information about where Starbucks is and where's my friend and how's the traffic and when's the next bus. All that stuff is kind of coming to you from many sources. So you create this pull and you just use natural gravity to flow that data out. So it's both of these systems together. And these are some lessons learned from the process that we went through. We started building our own BIM applications in the 90s because of the frustration we had of being able to move data between applications. We needed to not be trapped in a single application, but to be able to move it into multiple applications. And we said, okay, let's just start building our own in-house applications. And now we're a hybrid organization, and we're architects, but we're also software developers. And I think in the end, a lot of us that are architects and engineers and planners and builders are turning into more software development teams. The younger generation is already wired to build these apps. So think in terms of that. How can you actually leverage that? So when you get data in the cloud and you think in terms of big data that's non-BIM even, when you start connecting these pieces together, there's a lot of non-BIM data that's very relevant in the BIM world. What's the information about a city, the utility lines of a city, or the streets, or the weather patterns, or hazards, earthquake faults in California. These are broadcast out from organizations that have this kind of data. Where's the floodplain so I can decide where to put my building? That's all the kind of data that's out there that's very important for us as designers and architects. And in our view of all this, we've built things over the years that have allowed us to do this. And I'm not going to talk about the tools that we do here, but basically this is the approach that we have taken. And the opportunity that this has created for us is that it has brought us to owners that say, hey, you guys are thinking a little bit differently about information. Can you help us as an owner organization to do this, to either build our own applications like this, not necessarily to use our tools, but basically tell us how to build this approach to build apps that can connect our data together and not trap us in systems that we have to keep on investing in over the years. So it's about using the same data on multiple devices. It's the type of software you use is not important. That's no longer the discussion. It's not about what software should I buy. Yes, software is very important. It's about how do I get my data, the same data, into multiple applications. And this is where the standards and IFC and all the standards that are out there are great, because it gives you structure of where it should go, but also that web service that I talked about. How do I flow that into any device? So when a person picks up a mobile device like that and says, I want to place a work order for a building, that person that's doing facility management and work orders could care less about BIM, could care less about IFC, could care less about 2D or 3D. They just want to fix that piece of equipment. How do you communicate that with them and make it simple? And I've seen examples of this over the years, over and over, that we think that a complex BIM, as architects, engineers, builders, we say, okay, the complexity of that BIM is incredibly important for design and construction, but if we hand that whole complexity over to the facility management world, they don't need all that data. And COBE was a big breakthrough, and Bill East is going to be talking later about this as well too, but COBE was a huge breakthrough because it identified how you filter out the type of information that's important in facility management. So it's not all the data, it's about how do you simplify the information to give it to the next team that wants to use that data. And when you're using a services-oriented approach, you're not downloading the entire model. You're just hitting that piece of information. Just like you're not downloading every Starbucks in the world to your mobile device and then searching for Starbucks. It's hitting information telling you, here's a Starbucks right here within 300 meters from where you are, and then feeding it to you. Real-time information at your fingertips. And in some cases, you do need the whole model. So it's not one or the other again, it's both. But if you're stuck only in one world, then that's what you have to live with, the whole model. So that's the stuff that's really exciting for me, is thinking in terms of a transaction-based set of information. So, how many of you heard of BIM Storm? So BIM Storms we started in 2007 as almost like an experiment. We said, okay, we do a lot of US government work. We can't share US government work to the public. What if we take the lessons learned and the tools and the different tools that are being used there and the consultants and other people that we work with and bring them into a virtual environment, a charrette, a workshop, and see what we can do in 24 hours. This was the first one in 2007. This is John Messner's team in Penn State. There was hundreds of people around the world basically collaborating online, linking things together, both live on the web and then offline in other BIM applications. All the major BIM applications were involved as well. Revit, ArchiCAD, they were all in there as well too. Google Earth. And the students were involved. We basically gave them each tasks. Each person was doing a different thing. One person's looking at the site plan, another one's looking at the building plan, another one's doing a cost estimate, somebody's looking at Facebook or whatever they were doing there. This generation is basically wired for this real-time interaction and being able to make those kind of decisions. And these have continued. So in 2007, we started in LA. We had Build London Live BIM Storm in 2008. And then we've had over 35 of them over the years. This was a free event. We basically funded it with everybody basically gave volunteer time to it. And you would ask, why would you even be involved with this? This is the best marketing tool in some ways. We found that it's created opportunities for us and for other teams that have been involved in this, where owners and others saying, hey, if you can do this virtually, can you do this for our facility? So it's a way of collaborating and finding how different technologies work, and it's also a way of kind of broadcasting out what you can do. What's also interesting about this for us personally, it's allowed us to find the best people in the world to work with. For example, I no longer accept resumes. If I get a resume, I say, well, join this and show me what you can do rather than tell me what you can do. I don't care what you say about what you can do. Show me what you can do, and then we'll collaborate. That's the best litmus test I found. And these are ongoing. We actually were involved with the AEC Hackathon last June. It was a healthcare-focused BIM Storm healthcare hack. And this is still ongoing. This is with real government data, which I'm going to be showing next. So if you're interested in finding out more, just go to bimstorm.com/hack and join that. Build London Live, BIM Storm, that was a 2008. So this is one of the case studies of what resulted from that approach. This is the California Community Colleges. They have 5,200 buildings, 7 million square meters of facilities, 120,000 spaces, a database about their facilities. This was very unique from an owner's perspective. We've worked with the US government as well too, but this owner group actually had a database of their buildings and spaces. Most government organizations a lot of times can't even tell you if a building actually exists, let alone what room it is in the building. And this group knew nothing about BIM, could care less about BIM. So we came in and said, you have a good database. It looks like BIM to us, but we didn't say that. So we said, you have a database. We have systems on the web that we use our tools and we use GIS. What if we start hooking these things together? And within a month, there was a prototype made of one campus where you actually started seeing the graphics. And then they said, let's move to doing more districts. Let's do another campus. They had 70-something campus sites, 5,000 buildings. And we said, okay, let's not just do another campus, let's do the entire state, because you have a database. There's no reason just to take one campus. Let's link the entire state into a graphical format. So within a few months, we have the entire state of California in a low level of detail, quote unquote BIM, with spaces, the size of the space, the name of the building, the GIS location, how many students are in the space, how big is it, what floor is it on. That kind of information can be used for things like how much energy are we using per square foot per student. All that kind of stuff can start to happen at that low level of detail. And they had a lot of different types of uses, including facility management. And when we started working with each of these teams, we did not tell them, like the work order system right there, we did not tell them, you're doing a pull down here, but in the background there's BIM and there's IFC. Do you know that? You need to know about that before you can use this. No. We said, you're doing work orders, here's an app, go out and do your work orders. And as they're doing their work orders and collecting information in the background, it's feeding into that cloud, feeding into a BIM, feeding into Revit if we need it, or ArchiCAD or whatever. Basically, it's harvesting the big data that's being generated and pushing it into BIM, no matter which direction it comes from. Same data, many uses. And these are some snapshots of the different type of facilities. And what's really interesting about this, 5,000 buildings, no BIMs, right? But some buildings were being delivered as BIM. So you hit it from both directions. If a BIM is being delivered as a construction project, yes, you can feed it into the database. If you have no BIMs, you still have data about square footage and GIS location and footprint of the building that is still relevant for making decisions about where do we spend our money, where do we build the next laboratory or science building, how much space do we need per student, how are we doing on the condition of the building, where should we fix or not fix, all that stuff. And when detailed BIMs like this one on the lower right that originated in Revit come in, you plug it back into the system. But the rest was auto-generated by bunching up this data into the different locations in GIS and BIM format in the cloud. This was presented on TEDx. If you'd like to see more about that, you can actually Google it on TEDx City. So this is the next phase of this project. So the California community colleges is almost broke. They hardly had any money, almost no IT budget, yet we were able to do the entire state the way I described it to you. The Department of Defense and US government spends massive amounts of money, just throwing it out the window, on technologies that have been around for years that are basically bogged down in the way that they've been built over the years. We actually got an award for this a couple weeks ago at the National Academy of Sciences, National Press Club, for the Department of Defense healthcare system and Department of Veterans Affairs for their healthcare facilities, looking at the entire life cycle. And I'm going to tell you this story now, next, about how this came to be. But the reason we got involved with this project, they were looking in at the California community colleges and said, if California community colleges can do this with almost no budget, why are we spending millions and millions of dollars on systems that just don't work? So how can we bring that thinking into the way that we want to work? So the Department of Defense Military Health System, they have, combined with VA, they have about 210 million, 21 million square meters, 210 million square feet approximately, of facilities that include things like ships and planes and hospitals, different types of assets. This is a huge organization, obviously, but lessons learned from all of these projects, it does not have to be a large project or a large owner. It can start from a very small project, it can start from a very small team, and oh, by the way, we're just only 8 people. We're 8 people. Very small team, and we've kept that small intentionally, and then we collaborate with other consultants and engineers and programmers and whatever to build these teams that can support projects like this. It's created huge opportunities for us because of that agile approach to thinking of how do we connect. We don't have to build these huge offices and have a couple hundred people. We work with groups like that, but we're saying if we're nimble and small, it's a huge advantage, and it doesn't have to be for large projects. So this owner has a lot of assets, a lot of projects, ongoing, existing facilities, and they wanted to tackle the challenge of looking at the entire life cycle at many scales. They said, we have all these systems that don't talk to each other, databases about facilities, databases about BIM, databases about budgeting and finances. None of them talk to each other. They have to manually crosswalk data from one to the next, but they want to be able to look at the entire life cycle, end to end. And there was a series of roadmaps and strategic plans that were run through a contract through the National Institute of Building Sciences, and we worked with them on this to create a strategy of how do you do this. So we looked at the standards that were out there already about GIS, we looked at COBE, we used IFC, all those standards are great. We actually used all of these standards, but then looked at the entire life cycle of how do you bring that find my Starbucks, if you can find my Starbucks, why can't I find my medical equipment in a hospital approach to an owner like this. And this is one of their slides, the early slides that they said, okay, we're taking data, so they called it the blue dot, red dot. If you take the requirement data of what are we defining as a requirement as an owner to build, and we want to get it into BIM, that's the blue dot there, we need to get it into design. How do we communicate our requirements as an owner organization to the design and construction community? And then how does it go out as a red dot? This is basically COBE going out. How do we get data going out from the BIM and take it into facility management? And what they realized early on is obviously that's a very important task, but even before you get to the red dot, if your data is not structured well at the blue dot section, it always goes back to what do we call things and how are we structuring them to get it into the design and construction teams. Because you're starting at the handoff and you don't have your data structured well, so the focus ended up going back to let's focus on getting the blue dot portion running. How do we get our programming data into design and construction? And there was a series of other projects going into the full life cycle as well too. So the handoff problem, all these silos that we keep talking about, and we've seen slides like this before about how do we get data between different systems. But if you think in terms of how do we get data between different BIMs, This is where the standards become incredibly important, the IFC going from one BIM to the next. But we're still kind of living in a file, mostly in a file-based world. When you're taking a file of a BIM, you're basically taking an entire BIM and trying to transfer it to another tool. So it's not a transaction. It's not, I just need information about Starbucks that's near here. It's about, here's all the Starbucks in the world, and you filter it out and find out what you need. So you need both again, but the silos have created incredible challenges. And these approaches, by the way, have been shared. So one thing that's really incredible with this US government work is that we said, we'd love to work with this, but we think that everything that's found about this approach should not be hidden. It should be 100% public, because there's nothing secret about how you design and construct and manage facilities. That should be shared with the world, because with this kind of an open source approach, when you share your information, you get other ideas and other solutions that come to you. And this is important for this conference as well. We're obviously broadcasting out how to collaborate, and you're sitting here learning about how to do this. So hopefully it's creating ideas about how you can fit into this. But if you think in terms of how do you fit back into this and give back and forth, not only about in Ireland, but with the world. It's a worldwide thing now. How do we solve this challenge of climate change, for example, or how do we solve this challenge of managing facilities? It's really a worldwide thing. So we had another project with the Singapore Ministry of Health and other owners like this that basically use similar approaches to this challenge. So the important concept with the DoD and VA that we identified, and this is not something we invented, this is basically how a lot of this stuff in the cloud works and big data works. You take the data and you disconnect it from the application. We're all used to taking our data, putting it, what application do we need to buy to put our data in so we can store our data in it? But if you think in terms of disconnecting the data and then creating what's called a data service in between and broadcasting data out, the data becomes neutral, and then you can plug different applications on top and access the information you need. It's called decoupling the data from the application. And this, compared to the monolithic, this is the challenge that DoD and VA have. They have a lot of systems that look like what's on the right. Data is trapped in the application, both government-built applications and commercial off-the-shelf applications where the data is inside the application, and it becomes very difficult to move the data out. When you take the green box and you move it off to the left, then you're able to do a lot more things with that information in a modular approach. And if you think in terms of Legos, it actually helps you to scale that infinitely. It's the Greek orders again. It's built-in rules, simple rules that you can scale infinitely, not overly complex rules that nobody understands. Both are important, but if you make it simple, then you can scale it infinitely. And this is also published on the web. It's called IFM, FedIFM. It's a whole schema. It's a data dictionary. There are prototypes. There are actually apps that have been developed on the web, and part of them are in production right now. This is an ongoing series of projects that are driven by this set of tools that have been worked on for healthcare. So you can scale it infinitely into an ecosystem. You build this ecosystem of tools. So if we start from, taking a pause here, and we go back to the beginning, how do we start? And this is an actual project that we're constantly shadowing teams that are building projects. I'm not going to name the team here, but this is a large hospital project for VA from less than a year and a half ago now, actually. And you walk into an owner's hospital and you say, give us your floor plans or give us information about your facilities. You have to crawl the building and basically measure everything because nothing exists, or it's in conflicting formats, all these CAD files and whatever. This is absolutely incredibly frustrating because you can't even find, well, where's the radiology department? And you see where it says 286, is that 280? Do we call that 286? There's not even a consistent naming and numbering of just let's get the naming of rooms and departments right. It's so simple, it's not even BIM, it's just consistent naming does not exist. It just doesn't. Some owners are starting to get, like California Community Colleges has it, but starting there, this was like a month-long project of collecting information to even start the process of design and construction. So it's a counting problem, and this is a quote from Russ Manning at DoD, but we did not go to our architecture school or get a PhD or whatever to count things manually. There are tools that are great at counting information, where we're spending our lives kind of counting and collecting information. So how do we get past that? It's a very analog process. Even for VA, they have a website, but a lot of information is stored as PDFs, digital files that are kind of document-centric, that are outdated the minute they're saved as PDFs. So the requirements for a hospital stored like this are very difficult to get to. And they wanted to get to this mobile, I want to pull things up and just get to that. What is that, 286 radiology department? There should be no question about that, because it's stored somewhere that's an authoritative source. And I want to be able to pull up a floor plan of a building as one example. So these are some of the early prototypes that were built for them from scratch, basically, with different modules, using off-the-shelf modules and open source tools to build applications. And they are also challenged with a huge amount of time and effort going into facility management. They have 750,000 work orders per year. And we calculated 70 minutes per work order. It's millions of dollars of time just running back and forth from the desktop PC across the hospital to somewhere else, collecting information, running back to the desktop PC. And these people in the field saying, why can't we use mobile devices to get to the information? So it's just crazy amount of time on that. So if you look at an exam room like this, everything around it, the type of equipment, the size of the room, the floor finish, the number of air changes, this is all data that drives into the requirements of a facility. And they've had a system for years called the Space and Equipment Planning System, SEPS, that was behind a firewall. You had to be a government-approved person to jump in there to even look at what are the standards for a healthcare room. And then you output it as a PDF file and handed the stack of PDFs to the architectural teams and said, here's a 1 million square foot hospital with 2.5 million data points. That's your contract to deliver it back to us as a hospital. Just immense amount of manual, as we all know, time is spent in coordinating that. So we told them, what if you take that data? This took 2 years to convince, actually, going through IT and everything. What if you take that data that's now behind a government firewall and make it 100% public, with no login required, that anybody in the world can get to? And they said, wait a minute, you can't do that, it's government data. And we said, no, you're already publishing it as a PDF and you're posting it on the website. These are requirements of what does an exam room look like. It's not an exam room that's built in Washington, D.C. somewhere. It's the actual requirement data. What do we call things? How big are things? What type of equipment do we need? So that was a series of projects that were taking that data and making it web service enabled, that diagram that I showed you in the beginning. And I'm going to jump a little bit into a live demo here. So, and anybody can try this, actually. If you go to the seps2bim.org site, I'm just going to hit a few things here, but basically it has all the RESTful web service for the techie people out there. You can actually hit the RESTful web service APIs and figure out how to pull data. But I'm going to show one tool. There's a utility here that basically says, okay, you want to find out what a typical exam room looks like. And I'm going to put my email address in there. And I'm going to call up a dental exam room. And you could call it, there's a couple thousand different rooms. These used to be stored as static PDFs or static Revit BIM files. But this is actually hitting the government server, it's hitting our server, and it's actually building that dental exam room on the fly from their data today. So if their data changed, that information coming to me would also change. Let's see if I'm actually, maybe I'm not on the web anymore. Yeah, there we go, just came in. Yeah, so I got an email, created it. If I click on it on my iPad, it'll pull up on the iPad. But I click on it here, it basically launches a web viewer. It's, again, a free utility. We put a date stamp on there to show how fresh is that BIM, because if it's a month old, it might be outdated. But this is a live BIM built from their data with equipment in it that has attributes and everything. And if I want to create a COBE file from this on the fly, it basically builds a COBE file on the fly. If I want to take it out to Revit on the fly, it basically builds a Revit version of that on the fly. If I want to create it, let's do a SketchUp actually. So I've got a SketchUp file there. And if I go to SketchUp, it works the same in actually Revit and SketchUp is the same, and we actually have ArchiCAD Graphisoft building a version of this as well too. So let's see, where's my SketchUp? I'm not a SketchUp expert, but let's try it. So SketchUp, close that. Okay, so we have SketchUp there. And it saved, what I did when I hit export, it saved a very small XML file to my desktop, 37K. This does it for an entire hospital as well too, in Revit. But what this is doing is going and looking at that data that just came from the government databases, what goes in the exam room, then it's going to the 3D warehouse, grabbing that object, that medical equipment object, and placing it in the right location, grabbing the data from the government database of the attributes and putting them into objects. So it's basically building a BIM on the fly from government requirement data that could change at any minute. This is a real-time kind of building up of data. And if you open up the same thing in Revit, it would be the exact same model in Revit with the same objects and equipment. So this happened pretty quickly. After we told them to open their data up, other vendors like Trimble and Graphisoft and others started wanting to connect to it. It creates that pull. We don't have to ask people to get involved here. It becomes a way for a vendor like SketchUp, Trimble, to actually show what they can do with this. And it doesn't matter what tool you use, again, because if you use this tool in different BIM applications, you're basically seeing the same information. So there's a model. And if sorry, I'm not a SketchUp expert here, but if I grab one of these objects here, okay, that boom arm there, and I look at the attributes. These attributes came from the government database, including the GUIDs and the model number and whatever, so it's very basic information about that boom arm. I do not have to type anything into it. So the designer at this point, whether they're using SketchUp or Revit or whatever, they can start moving and pushing these things around to make design. This is a default template of their requirement of that. Yeah, I'm good. Okay, so that's one thing. And then the next thing that happened is a group called Atania has a medical equipment database. Again, knew nothing about BIM, knew nothing about IFCs, but they had a medical equipment database of 40,000 pieces of equipment. They took the same data and basically, whether you open this up in Revit or our system here, in fact, I could show the Revit animation. Oh, actually, it's over here, so it's good. So this is the same type of exam room here. If I open this up and look at the attributes about this piece of equipment, this is a web service link that, okay, so this is the default data coming from the government database. This just streamed in from the Atania server. This is real time. It's basically hitting the Atania server of this piece of equipment. A medical planner can be making decisions about what goes into this room, and it's flowing into BIM. This group, again, they knew nothing about BIM or IFC, but they're able to link through to that. So you start stacking all these pipes together, and incredible things like this can happen where you start being able to see the data in the early stages of design. And the same would go into, let's see, Revit. Let's see if this is, no, that's not Revit, in the iPad, whatever, but in Revit, if you open up the same object in Revit, it actually has the same attributes, so Revit or Navisworks. So it's not embedded in the Revit or Navisworks model. It's going back to the Atania server and pulling that data in here. Okay, so what are the lessons learned from this? There's ways to simplify things for the end user. If you're a designer, obviously you need the full model. If you're doing medical planning decisions, you can actually focus just that type of data to that user. And in the SEPS to BIM and FedIFM approach that we just talked about, we're having a lot of other groups, including groups like Aditas, which is a very interesting medical planning team that's building applications of how they can link to this data, and Atania was another example, but there's a lot of groups like this that are starting to show how they can either build applications, link their solutions in, or architects and consultants that are using this data to build using the design process. So you can try this yourself. It's on SEPS to BIM. In fact, I'll tweet this out after I'm done here. I'll tweet out the link to what I just built so you can actually try it yourself. And the last few slides here, this goes back to the concept of we need to give the data to the end user. So if you're a customer, let's say you're a patient in a hospital, you might want to find where is that radiology department. If you're a facilities manager or an engineer on site that wants to fix the equipment, you want to find where that piece of equipment is. It doesn't have to all be in one database, but if it's connected with the same IDs, you can start building applications off of this on the fly to build solutions for across the board. So you don't require everybody to be a BIM expert to get to the BIM data. And you allow multiple applications to be used or new applications to be built on top of that data. And you simplify. It's about taking the complexity and simplifying it. And I think that's the biggest opportunity that I see as an architect is because we understand the facility world. The biggest challenge of building software is not necessarily the coding of the software itself. It's understanding how buildings and facilities run and how they're put together. and the logic and the relationships. That's the complex part. It's that Greek order that I showed in the beginning. Just because you know what the rules of building a Greek column are, you're not going to build a Parthenon unless you know how to put the design together. You have to combine that design thinking with the technology and be able to focus more time on the design. So when we started on this path, what we were trying to do was basically automate everything that should be automated, counting things, databases, so we can spend more time on design that you can't automate. It's a value add that creates incredible opportunities. And this, I'll leave you with this final quote, which I love. It's from Balfour Beatty, Andreas Phelps. The shelf life of a good idea in today's world is 6 months. So you share it immediately or you lose that opportunity. In other words, the great idea that you have in your head that you're hiding for the next big thing that you're going to do, somebody else is already thinking of it. So if you wait for a year, you might get overtaken. It's better to open it up, and then you create these new opportunities that did not exist just within your own closed environment. It's not to say give away everything for free. There's ways of both being from a business perspective of creating new opportunities for yourself, but opening up. So in other words, share. It's a two-directional thing. You have to share and learn. And that's what this conference is about, sharing and learning and connecting and seeing what we can do together. And it's an incredibly exciting time to be innovative, to think differently, to collaborate, to intensify the architecture, and to build informed environments. So thank you very much for your time. I know this was a lot of material.